Okay, so you need to be able to write chemical equations on the AP exam, and the ones that people have most difficulty with are the net ionic. And we don't do this just with metathesis or direct replacement reactions, but double replacement reactions, we do it for all of them. And it's something you've got to get good at. Alright, so molecular equation lists the reactants and products in their molecular form. Now, I don't like this word molecular, so this is a bit of a misnomer because it's not just molecules, it's ionic stuff too, right? So it listed it in its compound form. So this would be considered a molecular equation. It shows the entire compounds in the formula. Okay? In the complete ionic equation, all the strong electrolytes and soluble salts are dissociated. So this is where you need to know what's a strong electrolyte, and those are the only things that you show breaking apart. So the silver nitrate, because it's soluble, we're going to show the silver and the nitrate separate. For potassium chloride, we're going to show the potassium and the chloride separate. But in our products, because silver chloride is a precipitate, we don't show it as ions. We show the potassium when we show the nitrate. Okay, and then to show the net ionic, what you're going to do is you're going to eliminate any ions or any substances that show up on both sides to simplify it, and you end up with this. Now, some people think it's easiest to write the complete molecular, break apart the strong electrolytes, and eliminate the spectator ions, right? Things that are on the same side. Others think it's easier to figure out what the precipitate is going to be, and then just to write what it is that produced that precipitate. So it's what you're most comfortable with. Okay, so anything that didn't change, we call those spectator ions. Those are the ions that just watch. They don't play the football game, they just sit in the stands and watch, right? They're there in the beginning, they're there at the end. Alright, so the simplest way is to write a net ionic is to write a balanced molecular equation, dissociate all strong electrolytes. So those would be your strong acids and bases and all of your ionic compounds. Cross out anything that remains unchanged as you go from the left to the right, and then the net ionic is whatever remains. Okay, so we're going to talk now about acids. Arrhenius, as you know, defined acids as a substance that produces a proton or an H+, increases the concentration of H+ when dissolved in water. Right? Bronsted and Lowry define them as proton donors, so that's really, for both of them, the same thing. There are only 7 strong acids. There are lots and lots and lots of acids, but only 7 of them are strong. So it's those that are made from those 3 same halogens we've seen before, and those that we tend to use in the lab: nitric, sulfuric, and then remember chloric and perchloric. Okay, you gotta remember those. Arrhenius defined bases as substances that increase the hydroxide concentration when dissolved in water, and Bronsted and Lowry define them as proton acceptors. Bronsted and Lowry's definition is broader. It doesn't have to have a hydroxide to be a base. And if we want to know which bases are strong, it's basically the bases of these group 1 metals and the bases of these 3 that are always together here in all of our rules: calcium, strontium, and barium. So if it's a hydroxide of alkali metals or those 3 alkaline earth metals, it's going to be a strong base. Otherwise, the base will be weak.